All right, so we're going to work on section 7.2. We're going to find and interpret the area under a normal curve. Then we're going to find the value of a normal random variable, and you're going to be learning some new stuff with your calculator. So make sure you have that handy. Also, before we begin this section, you're going to need the z-table. And the z-table can be found on My Open Math. You can see it right here, right under the final project presentation examples. There's the Z and the T table. It's all one document. The T table is the second page, so you need that first page. It's table 5. Don't look at table 6. It's totally going to mess you up. It's also in the back of your book, so just look for table 5 in the back of your book. It's a little bit easier to read than the one online, but you're going to need that because I'm going to show you how to read that and how to interpret it. And eventually I'm going to show you how to do this without with the calculator, without the table, but you need to be able to read that table. Right, so let's go. So standardizing a normal random variable. So we already talked about the normal curve and what that looks like in 7.1, and we worked with that a little bit. But what it means to standardize a normal random variable would mean we convert all of our x's to z-scores. Z-scores normalizes everything. So remember when we were doing the example a while back when we were trying to figure out which basketball player was relatively taller, whether it was the female one or the male one, and they had different scales, but when we brought it to z-scores, it kind of normalized it. It's the same thing here. I think the other one was batting averages or total wins or something like that of baseball, but this just normalizes it. So we're standardizing it when you convert all of your x's to z-scores. It makes it a little bit easier because then your mean is going to be 0 and your standard deviation is always going to be 1 when you convert to z-scores. So that's what this is right here. So mu equals 0 and standard deviation equals 1. So make sure when you are using those z-scores, your mu is 0 and standard deviation is always 1. So that's something to keep in mind as we move on. So remember, in order to calculate the z-score, we do whatever your data point is minus the mu and then divide it by the standard deviation, and that calculates the z-score. Okay, so I want you to look at this. So the normal distribution, this is a normal distribution on the left here, this green one. See here? So this green one here on the left, this is a normal distribution. Once we have standardized it, once we have a standard normal distribution, look how my mean here, let me do a better color. My mean here is 0. The mean over here on the normal distribution is 1010. So the mean of the standard normal distribution is always 0. And then my standard deviations, looks like the standard deviation on the one on the left is 20. So one standard deviation on either side. We have 1030 and 990. When you get to the standard normal distribution, my standard deviation here, one standard deviation away, my z-scores are 1 and -1. Makes it so much easier to see where those outliers are, because as soon as you get larger than 2 or smaller than -2, you know that it's an outlier. So it's a lot easier to look at it and just see where those unusual values are. So this is something you are going to need to know and remember for tests and quizzes. The standard normal distribution is based on z-scores, is when everything's been converted to z-scores. A regular normal distribution uses the actual values of the data rather than z-scores. So remember that. You'll need that on a test. Okay. So IQ scores can be modeled by a normal distribution with mu of 100 and standard deviation of 15. An individual whose IQ score is 120 is 1.33 standard deviations above the mean. So right here, I have normalized that. I have calculated the z-score. I took 120 minus 100 and then divided by 15, and I got that z-score of 1.33. We've been calculating z-scores for a while here, so this should be something super simple for you. So I want you to take a look here. We are going to be calculating the area under the curve to the left of that 1.33. So I'm going to go back here real quick and show you. So here is my normal curve, course, always drawn perfectly. And my mean is right here. So my mean is, what is my mean? Mean is 100. Standard deviation is 15, so this would be 115. This would be 130. So I'm looking at about 120 would be right about here. This would be about 120. So I'm looking for this point here, which is 1.33 standard deviations. I want to know the area under this curve to the left. So I want to know how much is this. We talked about area under the curve in our last section. I need to be able to calculate this area under the curve right here. So I'm going to show you how to look that up on your z-table. So here's my z-table. It looks a little bit different than yours because I cut out just enough to get the numbers that we need. So the way that we look for this, what the z-table does is it helps us to find the area to the left of any z-score. We used to not be able to do this in a calculator, so we had to use z-tables. So the way that we read this, so your first two numbers, so the 1.3 right here, I'm going to look on the left side and go down, see where it says z, so you get the first two digits, 1.3, so one number after the decimal point, and I come all the way down to here. Then you move over to the column that corresponds to that second digit, so that digit that is in the hundreds place, we move over to that column. So right here, notice that this is 300ths, so I go to this number right here. So this tells me that the area under the curve to the left of my z-score of 1.33 is 0.9082. That is what that's telling me, is that area under the curve to the left of that is 0.9082. I'm going to show you a drawing of that 1 second here. So here we go. So I can see that area right there, see how that area under there corresponds to 0.9082. What if I wanted to know what percent of the population has an IQ higher than 120? I know that 0.9082 or 90.82% has an IQ that is 120 or lower. I want to know what percent of the population, or what proportion of the population has an IQ score higher. So you have to do the complement rule. So you do 1 minus that 0.9082 and you get 0.0918, or 9.18% of the population has an IQ of higher than 120. My z-table does not do to the right of the z-value, so you have to calculate that yourself using the complement rule. I'm sure you want to know how to do that on the calculator, right? I'm going to show you. So here we go. We're going to use our second vars key. So we'll use second vars and then go to normal CDF. So remember we did second vars before and we scrolled all the way down to the binom CDF. This right here, second vars, and then normal CDF is your second choice. So your lower, we want to know, here I want to know what the area of the curve is under -1.2, a z-score of -1.2. So the way that you can put this in your calculator, if you have a TI-83, you're going to have to do normal CDF, lower z-score, then upper z-score. So you'll have to put it in that way, but if you have a TI-84, that'll give you a screen like this. It'll give you a screen like this. So your lower, I'm going to show you how to do this. That's negative infinity. So that's just basically going as small as you possibly go. The way that you put negative infinity into your calculator, let me erase all of this. The way that you put negative infinity into your calculator is you do, and I can't even see it here. Oh, second, and then comma. If you can see right above the comma, it's hard to see it on here. It says E. So you do second, and then the comma, That's a comma, comma. And then 99, that'll give you just E99. Just make sure you put the negative in front. Sorry, so do negative second comma 99. That gives you negative infinity. If I wanted positive infinity, I would just do the second comma 99. So once again, let me write this again. So negative, which is that little key at the very bottom that looks like this, second comma 99. Okay, and then my upper value, because I want less than negative 1.2, my upper value would be negative 1.2. Remember, the mu and standard deviation are 0 and 1. When you are using z-scores, your standard deviation is always 1. Your mean is always 0. So once you put that into your calculator, you will get 0.115. So the area under the curve less than negative 1.2 is 0.115. All right, let's move on. So now the area under the curve, we just talked about this. If I want the curve to the right, I do 1 minus the area to the left. You only have to do this if you're using the z-table. Otherwise you could do, like for example, if I wanted z greater than 1.2 or negative 1.2, then I would do normal CDF, and then I would do negative 1.2 comma E99. So when you're using your calculator, you don't have to worry about that complement rule. Your calculator can do it for you. You only need to worry about that if you're using a z-table. Okay, so now let's take a look here. So remember, if z equals 0, if my z-score is 0, that means it is the mean. That means the area under the curve to the left and to the right are both 50%. They're both 0.5. What about if z is greater than 1.3? Let's take a look at that on my z-table. So here's my z-table. I cut it a little bit because I don't need all of the rest of that and it needs to fit on my screen. So I'm going to show you once again how to find this. So the first thing I'm going to do is look for 1.3. I see that right there. So what is the number in my hundredths place? The number in the hundredths place is a 0, because if I have 1.3, the next number is 0. So I need to find the value that is in the 0, 0 column and the 1.3 row. So that would be right here, 0.9032. So I got 0.9032. If I put that in my calculator, I should get the same thing. If you put that in your calculator, do the 1.3 E99, you will get the same thing. All right, let's move on. So I need to find the area under the standard normal curve between z equals negative 1.02 and z equals 2.94. I'm going to do this on the calculator, and I'm going to do it with a z-table. We're going to start with the z-table. So let's start there. So here's my z-table. So I had to cut a whole lot of it out here. So let's look at a couple of values. Actually, let me go back. Let me draw this first. So I'm going to draw this. Ooh, that one's not too bad. Okay. I know that since I'm using z-scores, my mean is 0. Here's one standard deviation. This is negative 1. This is 1. This is 2. Negative 2. And I need to go to 3. This is really ugly, but there's 3. Okay. So let's start with, I need it between these two values. So let's see, so my 2.94 is about right here. This is about 2.94. I'm just grabbing some numbers or some areas here. Negative 1.02 is about here. So what I'm looking for, I need the area of all of this in here. This is what I need right here. So what I can do, and we did something like this before, I can't remember what it was with, but if I look at my z-table and I find the 2.94, I'm going to get all of this. I'm going to get the area of all of this. And if I use the z-table for negative 1.02, I'm going to get all of this. So can't I take this right here and then subtract that off? If I subtract this off, I'm going to have just this area that I want, right? So if I take the whole 2.94, so if I do the 2.94, that area, then subtract the area for negative 1.02, then I'm going to end up with just this piece that I need. So let's do that. Oops, and that was really ugly drawing. I'm hoping you understood that. So let's take a look. So I'm going to start with my 2.94. So here's 2.9 and go over to the column that has 0.04 because that's my hundredths place. And I get 0.9984. 0.9984 minus, and I have negative 1.02, so here's negative 1.0, here's the 2, so I get minus 0.1539. Let's stick that in my calculator. That's my wrong thing. I probably could do it in my head, but I'm not going to do it because that's when I make mistakes. Okay, so I got 0.8445. Let's see how we do when we use, our calculator. Oops. Let's try it. So I'm going to put, my lower is negative 1.02. My upper is 2.94. Remember, your standard deviation is 1 and your mu is 0. I got 0.844, and if I round it, 0.8449, well, that's not an eraser. That's perfect. It is the same answer. Yes, it's much easier with the calculator, but it's good to know how to use that z-table. It will come in handy later. All right. So problem, if we're finding the area to the left of x, shade that area to the left of x, convert the value of x to a z-score, then use table 5 to find the row and column that correspond to z. The area to the left of x is the value where the row and column intersect. This is one method. The other method, convert to z-score and then use your technology. Use your calculator. That's what I recommend. Definitely during a test, I recommend that. It's going to take you a lot less time. Right, so what if I want to find the area between two values? Convert both of them to z-scores. If you're using your table, the area to the left of z2, subtract the area to the left of z1, or just use your technology. And I definitely recommend using your technology. And I apologize for my dogs barking. All right. So when we are calculating our probabilities of normal distribution, method 1 is not this. The method 1 is to not convert your z-scores and just use A and B, which are your upper and lower bounds. Just put in normal CDF just what your upper and lower bounds are. So for example, that IQ problem, I would do normal CDF, my lower bounds, if I'm, actually let's say we're looking for greater than 120, I would do 120, comma, E99, comma, my mean was 100, and my standard deviation, I think it was 10, so we're going to pretend it was 10 even if it wasn't. So this is how I would put it in. This is the mean and the standard deviation, my lower bound, and my upper bound. So method 2 is by using z-scores. So you would use your normal CDF, put in your lower z-score and your upper z-score. Make sure that if you're using a TI-84, make sure that your mean is 0, your standard deviation is 1. Okay, moving on. This is just kind of everything put into one spot, all of the methods. Make sure that you remember the negative E99. If you can't remember negative E99, if you put in something like negative 1,000 or negative 9999 or something like that, you're going to get the same answer because everything's going to be represented. But this is your best option for infinity or negative infinity. All right. So sometimes we want to find a value of a normal random variable that corresponds to a certain proportion. So let's say we know the proportion. We know the percent that we have. We're looking for a percentile. And we want to know what value represents that. Like what if I wanted to say that my IQ is in the 95th percentile? Say, well, what is that IQ score that puts me at the 95th percentile? Or what if you took your child to the doctor and they said, oh, his weight is in the 87th percentile, but they didn't tell you how much it showed on the scale, or maybe it had it in a different system. Maybe it was in the metric system and you don't know how to do that conversion. You can put it into your calculator if you know the mean and the standard deviation, and you can figure that out. All right, so let me show you this and we can figure this out together. So we may want to know the height of a 2-year-old male who's in the 20th percentile, or we might want to know the scores of a standardized exam that separate the middle 90% of the scores from the bottom and top 5%. This is all stuff that we might need to figure out, and there's an easy way with the calculator, and there's a way with your, there's a way using the Z table. So let's get right to it. So here's our procedure. First, draw a normal curve. Shade the area corresponding to the proportion, probability, or percentile. These are all the same thing. Next, use your table 5 to find the Z-score that corresponds to the shaded area. We're going to do all this. It'll make sense once we do it. Then obtain the normal value by using your mean plus your Z-score times the standard deviation to find what that value is. We're going to do this by hand, so that will make sense in just a moment. Or you can use your technology. This is our new thing right here, and this will save you. Use inverse norm on that second vars. That's your third choice, inverse norm. This is you put that probability in. Put that probability in and your mean and standard deviation, and it will spit out the value that lands at that spot. So let's get right to it. Okay. So the combined score on the GRE is normally distributed with a mean of 1049, and that should not have been a pen, and a standard deviation of 189. We want to know the score of a student whose percentile rank is at the 85th percentile. So in order to figure out where to start looking at our Z table, we know, we can see, this is our, remember we used this for the empirical rule? So we know that this right here, 50% lies above the mean and 50% lies below the mean. Since this right here is that 68% within one standard deviation, if I add the 34 to 50, I get 84. So I know that the 85th percentile is just slightly outside that one standard deviation. So that 85th percentile is going to be right about here. So I'm looking for a number slightly larger than 1 for a Z-score. So let's look at our Z table and take a look at this. So I know that it's going to be slightly larger than 1. That's why this is all that you got from your Z table. You are going to actually look in the values in all of this stuff in the middle of your Z table to find a number that is close, really close to 85, because we're looking for the 85th percentile. I'm looking for 0.85. So if I'm looking for 0.85, you look right here. I've got 0.8485 and 0.8508. Just choose the one that is closest to 0.85. So that's going to give me this right here. So 0.8508 is really close to 0.85. That corresponds to the z-score of 1.04. So that z-score that I get is 1.04. You see how this is the 1.0, that's the tenths place and the whole number, and then 4 is in my hundredths place. Uh-oh. So my z-score is 1.04, so what I'm going to do is I'm going to take that z-score right there and multiply it by the standard deviation and then add it to the mean. So that score, so the GRE score that is at the 85th percentile is about 1246. Let's see what happens when I put it in my calculator. Let's see how close we get. So we had 1246. All right, let's take a look. So I'm going to put it in my calculator. So you go down to the third choice here. Inverse norm is your third choice when you do second vars. So second vars, my third choice is inverse norm. So my area under the curve is 0.85, mu is 1049, and standard deviation is 189. I got those from that last page. So that gave me 1244.8859. So that's really close. It's slightly less than 1246, but I think it's close enough that nobody's going to argue with me about it. So that's how we would put it in our calculator. Let's do another example. So I want you to try this one. First, try it with your Z table, and then try it with your calculator. So the weights of giraffes are approximately normally distributed with a mean of mu equals 2,200 pounds and a standard deviation of sigma equals 200 pounds. So before you do this problem, make sure that you figure out approximately where on the curve it lands. So go ahead and pause, try this problem, and then come back and we'll do it together. All right, so I hope you did it on your own. I hope you were successful. So 75th percentile. So remember, we figured out that this right here was 84. So we know that 75th percentile is going to be somewhere in here. So it's going to be somewhere between 0 and 1 on my for my z-score. So somewhere between 0 and 1. So I only gave you that piece right there. So I'm looking for 75th percentile, so 0.75. So I'm just going to look here if I can find 0.75. So 0.75, I've got 0.7486 here, 0.7517 there. 0.7486 is slightly closer to 0.75, so I'm going to take that one. I wouldn't mark you wrong if you took the other one. So my z-score, 0.67. So my z equals 0.67. So I'm going to do 2,200 plus 0.67 times 200. Let me throw that in my calculator real quick. And I got about 2334 pounds. Let's see what happens when we put that in the calculator. See how close we get to the same answer. So here I put 0.75, 2,200, and 200 in my calculator. And my answer is 2334.897. I think it might have been a little bit closer had I chosen the higher z-score. If I would have went with the higher number. Close enough though. I don't think anybody's going to fault me for being less than a pound off. So a giraffe in the 75th percentile is about 2,334 pounds. So what do you think we would do here? So here, I know that the length of a certain steel rod is normally distributed with a mean of 100 centimeters, standard deviation of 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. So we need to know the middle 90% of the steel rods manufactured. I'm going to show you the slide on the other page so you can see it. So here we want the middle 90%. So our middle 90%, if I sketch that, I have to have 5% down here not used and 5% up here not used. So we are taking 10% off, so half of that is removed from each end. So let me show you here. So this area right here is 0.05. This area here is 0.05. So this point is the 0.05. This right here is 0.95 because I'm taking that away from 100. So if I looked at my z-score table, which I didn't do that on here, I would get this as my z-score. It's going to be the same, the positive and negative. You're going to see that with all of them. So probably what I would have done with my z-score is looked for 0.95. I probably can get back to a z-table here. It's where I can do that. So like looking for 0.95. Yes. So this z-table here, looking for 0.95 here. So 0.95 is right about here. 0.95 is right about here. So you see I have 165 would be my z-score, and then just use the negative for the other end. Let me go all the way back. Okay. Sorry about that. Okay. And so I took my mu plus z times my standard deviation. And I got 99.26 for my lower end. So for down here is 99.26. And then I had, so one of them I subtracted, so this one should have been a subtraction. Oh, it's negative, never mind. I lied to you. So then I do it with the other side. So I'm doing, this is the negative 1.645. Here's the positive 1.645 times 0.45, which this was my standard deviation. And this is the upper. So we can see that all of the steel rods that make up the middle 90% are between 99.26 and 100.74 centimeters. So make sure when you are doing these problems, you are looking at the center 90% or the center 80%. You're not just taking that 80 and finding the area under the curve below that. So if you have any questions, make sure you send me an email or shoot me a message through My Open Math. And there's a couple other videos on this section that are really helpful that just give you another perspective on it. So I will talk to you later. Bye.